Hello everyone. So that's my talk, and in this figure I'm showing you the typical temperature forecast for a period of 10 days. The light blue curve here is the dark blue curve is the truth, and the light blue curve is the forecast. And you can see that forecast starts out pretty close to the truth, but as the time increases, it gets away and away from the truth. And the difference between the two curves is the error. So you can see that with the increase of time, the error gets increases. That means the predictability is decreasing with time. And the mean square of this error is called the mean square error, which is measure of predictability. In this figure, I'm showing you the mean square error in black curves with respect to time, number of days. And you can see that mean square error is increasing with time. And this red line is the no-scale line. That means error coming from no-scale model. So when this black line hits this red line, we say no predictability is left. So this figure tells you that the limit of weather predictability is around 10 days. So I'm interested in finding an index that can be used to maximize the predictability on longer time scales. So what I do that I try to maximize this area using some sophisticated techniques, and which I call average predictability time, or APT. This is what I'm trying to do and see what happens. Here I'm showing you the schematic representation of what happens in the nature, in the atmosphere and the ocean. The important thing is that the ocean has some of the processes like the circulation, overturning, and mixing and all that, which have the time scales ranging from days to decades. And that's why you expect that the time scale of the prediction will be longer than what you get from the atmosphere only. And any coupled model is supposed to simulate these patterns. So what I'm trying to do, I'm going to compute the APT stuff in the coupled atmosphere ocean model and trying to see what happens. So when I do the computations, this is the most predictable pattern coming from the fully coupled model. And those who are from my field, they can recognize that this pattern resembles the Pacific decadal oscillation. This shows the error growth of the most predictable pattern coming from the coupled model. And as you can see, it is increasing with time, but I get multi-year predictability using a fully coupled model. So now the interesting part, what I do, that I replace the ocean with the slab ocean. That does mean that it is exchanging energy with the atmosphere, but there's no circulation. Does that mean the time scale is decreasing of the prediction? So I did the computation, and interestingly, I found that the pattern is very much similar to the coupled pattern. And the most interesting is that I still get multi-year predictability by just using slab ocean model and no ocean circulation. So this is what I get. And I think that model suggests that we get predictability without ocean circulation. Thank you.